Hello everyone. So in this particular video, we will be studying about a topic of permutations and combinations. Now this particular topic is related to division and distribution, that how I will distribute certain number of things in some certain boxes. So I'll be taking a topic in that. So this is division and distribution. And in this particular topic, I'll be studying or will be discussing about how will I distribute n identical things in r distinct boxes. So this is basically distribution of n identical things. So remember the things that we are keeping in, we are trying to distribute in the boxes, those are identical things. That means what that means in this case, how the number of the things in a box matters and not the things matter, because all the things are identical. And identical things in are distinct boxes. So let me just give you a quick example. So suppose I want to distribute 5 identical things in 3 distinct boxes. So I've named these boxes as A, B, and C. And I have 5 distinct things. 5 identical things, sorry. 5 identical things. So right now I'll be asking you, in how many ways I can distribute 5 identical things in these 3 boxes. So what are the number of ways? So number of ways can be, I put 2 things in A, 1 thing in B, and 2 in C. This is one of the solution, or this is one of the way I can distribute 5 things into these boxes. Now what these 2, 1, 2 things are, they don't matter. They can be anything. The thing is, they are identical. So that doesn't matter. I don't have to choose these 2 objects. I'll just simply put 2 in A, 1 in B, and 2 in C. Now, another solution could be, I will put 1 thing here, 2 in this bag, and 2 in this bag. So now these 2 are distinct solutions. That means 2, 1, 2 and 1, 2, 2 are distinct solutions. Why? Because now the objects, now our boxes are different. So putting 2 things in A, 1 thing in B, and 2 things in C is different from putting 1 thing in A, 2 in B, and 2 in C. So now let us try to find out the number of ways of putting n identical things in r distinct boxes. That means we are generalizing the case. So we'll find out the number of ways in terms of n and r. So now, suppose I have n identical things and r distinct boxes. So I can say this problem of putting n identical things in r distinct boxes is same as what? This is same as finding, and yes, empty boxes are also allowed in this case. That means even 500 can be a solution. So this is particular case where empty boxes are also allowed. We'll do when empty boxes are not allowed also. So in this case, let's say empty boxes are allowed. Now what I'll do, I'll just draw a parallelism of this topic to another problem, which is finding the number of non-negative integral solutions. So what do you mean by non-negative integral solutions? That means they are basically natural numbers with the zero. Non-negative integral solutions of the equation. X1 plus X2 plus X3 plus X4 up to XR, which is equal to n. Now you'll ask me how. So basically X1 to XR is equal to n. What do you mean? How is this problem related to that? So see, the simple thing is, if I'll just give you an example of that also. So the number of ways of putting 3 5 identical objects in 3 boxes. So the solution is 0, 5, 0, 4, 1, 0, and so on. So I can say if I need to find the number of solutions of this equation, x plus y plus z is equal to 5. I can say x1 are the number of the things that I put in the first box. X2 is the number of things that I'm putting in the second box. X3 is the number of things I'm putting in the third box. And XR is the number of things that I'm putting in the RS box. That means the last box. So collectively, these the number of items should be equal to n, correct? Because I have to put n items. Now, say I put 1 in first box. The value of x1 will be 1. Or I'll say x plus y plus z. Suppose I put 5 objects in first, 0 object in second, and 0 object in third. So 5, 0, 0 is also a solution of this equation, right? 0, 4, 1 is also a solution. That means I'm putting 0 things in first, 4 things in second, 1 thing in third. Then 4, 1, 0 is also a solution because I'm in this problem, I'm saying a value of x is 4, value of y is 1, value of z is 0. That means I'm putting 4 objects in first box, 1 object in second box, and 0 objects in third box, and so on. So I can say this problem is same as finding the number of non-negative integral solution of this. Now, also this problem is same as what? This problem is same as finding the coefficient of x to the power n in the equation. Which equation? In the equation x to the power 0 plus x to the power 1 plus x to the power 2 up to x to the power n. Same here. Same for third case. And same for the last. And this will be repeated r times. Now how? So finding the coefficient of x to the power n in the equation. Again, I'll just give you a particular example. Same example of putting 5 identical objects in 3 distinct boxes. So what I'll say that how my x to the power 5 is forming in this equation. 1 plus x square up to x to the power 5. Then again. Now, the powers of x in each bracket corresponds to the number of objects I'll be putting in the first box. So the options I can do, the options I can have, or the options which I have, that I'll put some certain objects in first box are either I can put 0 objects, or either I'll put 1 object, either I'll put 2 objects or 5 objects. So the powers of x corresponds to the number of objects in first box. The power of x in the second bracket corresponds to the number of objects I'll be putting in the second box. And again, same for the third box. Now, how x to the power 5 will form in this expression, let's see. So I can say when this x square will get multiplied to x here, and this x gets multiplied to x square in this bracket. So x square gets multiplied to x and then gets multiplied to x square here. So that means that is one of the way of forming x to the power 5, right? So that means I'm putting 2 objects in the first box, 1 object in the second box, and again 2 objects in the third box. So this is one of the way of x to the power 5 to form in this particular expression. Now, the total number of ways will be the total number of solutions of our equation. So how x to the power 5 will be forming in this equation will correspond to the total number of solutions, because every time x to the power 5 comes, that will correspond to a solution. One of the thing is when x to the power 5 in the first bracket will get multiplied to 1 in second and will get multiplied to 1 in the third bracket. That means the solution corresponding to this particular thing will be 500. And that's how the number of ways in which x to the power 5 will form in this expression will, and each way will correspond to a solution. So we can say whatever the coefficient of x to the power n will be, or whatever the coefficient of x to the power 5 will be here, those many will be the number of ways of putting five objects in three boxes, right? So for generalization, I'll find the coefficient of x to the power n in this equation. Now, as you can see, this will be 1 plus x square up to x to the power n whole to the power r. So now our problem of the permutation and combination reduces to finding the coefficient of x to the power n in this particular expression. So finding, or you can say, this is the coefficient of, we need to find the coefficient of x to the power n in this particular expression, 1 plus x square up to x to the power n whole power r. Now, as you can see, this is a GP. This is a GP with common ratio as x and the number of terms as n plus 1. So I'll put the formula of GP. This is 1 minus, the first term is 1. So a into 1 minus r to the power n, number of terms, divided by 1 minus r. So 1 minus x to the power number of terms divided by 1 minus r means the common ratio and whole to the power r. I need to find the coefficient of x to the power n in this. Now this can be written as 1 minus x to the power n plus 1 whole to the power r multiplied by 1 minus x to the power minus r. Now consider this expression, 1 minus x to the power n plus 1 whole power r. Now when I'll just expand this with binomial theorem, the power of x will be greater than n plus 1 every time, because how will we expand this? 1 plus rc1 into x to the power n plus 1 to the power 1, then x to the power n plus 1 to the power 2. So every time, every term in this expression will contain the power of x which is greater than n plus 1. So how will I find x to the power n in this? So there will be only one term, which is 1. And this 1 will get multiplied to x to the power n here. And that will give me the coefficient of x to the power n, because every other term in this first expression will be greater than x to the power n plus 1. So when that gets multiplied to this, the powers will be greater than x to the power n plus 1. So I'm only interested in the first term, which is 1. Now I'm interested in finding the coefficient of x to the power n in this term now. So let's just expand it using negative binomial theorem. So this will be 1 plus rc1x. Next term will be r plus 1c2x square. This is how negative binomial works. So we won't have any negative power of x. All the powers will be positive, and this will be an infinite expression. So r plus 2c3x cube plus r plus 3c4 x to the power 4, and so on. We are interested in finding the coefficient of x to the power n. So as you can see the pattern, the coefficient of x to the power n will be, here we'll have cn. This is, if this is 4, if this is x to the power 4, here I am getting 3. So if it is x to the power n, I'll get n minus 1. So this will be the coefficient of x to the power n, which is n plus r minus 1 cn, which is also equal to n plus r minus 1 cr minus 1 using the properties of binomial coefficient. So this will be the coefficient of x to the power n in this particular expression, and this will also be the number of ways in which we can put n identical things in r distinct boxes. So, and also empty boxes are allowed. That is important. That means I can have 500, I can have 050, I can have 410, I can have 320. Empty boxes are also allowed, right? So this will be n plus r minus 1c, r minus 1. Thank you.